good afternoon. The subject name is compiler design. In this subject, we are going to discuss. We have discussed previously some of the concepts which are related to optimization and code previous, that is intermediate code generation, syntax derivation. Now, in this, what is some of the problems previous also discussed, that is optimization, and in this code generation techniques. Now, let us move into one example, that is a given graph. In this given graph, the edges are to be taken place. That is, what is the edges that is to be considered? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the nodes. In this example, the graph consists of nodes and edges. So here, let us see the nodes and edges. So here, there is one node that is in the given graph, the node starting, that is here. We are going to identify what are the dominators and what are the different trees that is formed from this header node, from this node. Dominator tree for the given graph. Dominator tree for the given graph. So here first we will look into first one. See one here, this is depends, that is 2, it is a node which is dominant. T dom n, in the previous example also we discussed. So like suppose 7, that is 2 mod 1, that is 3 mod 1, that is again another node. So suppose here 3 also, node 1, node 2, node 3 to be considered. From 3, see here from 2, no need to write the edge part. Why? Because here it is depends on only 2 and 3. Node 1, 2 and 3. So where is node 2, that doesn't have any other even though association with 3, but the association not required for this. So here 3, in this the node 3, the association for the node is 4 only. And 4, we know that the association for this node is 5, and 6, 4, 6, and then 7. So in this graph, we are looking into this graph, 4, 5, 6. 4, 5, 4, for 4, 5, 4, 6, and then 5, 6, 7. Okay. Now here there is no direct association. That is direct association. There is a edge 7 to 4. So that's why here we are not representing the direct edges, only edges. So that's why it is there. So that's why 4 dependents, that is 5, 6, 7. And 7, there is 8. And for 8, 9, and then. So here some of the edges forming a loop. So 4, suppose for example 4, 3, 4, 3, 4 to 3, and then 8 to 3. So 4, 3, 8, 3, and 9, 1. These are forming loops. These edges forms the loops in the flow graph. And there is suppose back edges and dash d. Here the edge to the d plus set of nodes it reaches to n without going through d. So node d is the header of the loop. Here n d for header of the node d is the header of the loop. Node D is the header of the loop. And the next one is reducible flow graphs. So in this main example of reducible flow graph, in this example, from this graph, another graph, so we have reduced that, reduced into some other notation, that is where the loops and some of the other transitions are eliminated. So here in this case, reducible flow graphs, loop analysis, every set of nodes as a loop must contain a back edges. The property is every loop must contain a back edges. So here, for example, in this graph, node 2 and 3, there is no back edges. So it is a non-reducible flow graph. What is non-reducible flow graph? Non-reducible flow graph, there is no back edge. If you remove the back edges, that is 4, 3, 7, 4, 8, 3, 9, 1, 10, 7, the remaining forward edges forms an acyclic graph. Hence, it is reducible. That means we are making a non-reducible into a reducible flow graph. Here we are going to remove some back edges. 4, 3, 7, 4, 8, 3, and then 9, 1, and then 10, 7. See, these edges are, that is 4, 3, 7, 4, 8, 3, 9, 1, 10, 7. These edges are forming a loop, that is. So this is to be avoided, and remove all the back edges. We are going to remove, and the remaining are all forward edges. This is a back edge. That means this is from 9 to 1. This is 8 to 3. Backward edges. So that is reducible flow graph make non-reducible into reducible. Where reducible flow graph, where loop must contain back edges. So this is a reducible flow graph. Reducible flow graph where the loop analysis, which contains set of nodes, each node has some back edges, several nodes that are as several loops. In the loops, it must contain back edges. Now, but in case of this, in this example, if you observe 1 to 2, 2 to that is 2 to 3, and 3 to 2. Now it is considered as non-reducible. Here there is no back edges. Here there is no back edges. It is a non-reducible. So here a reducible flow graph where set of nodes must contain a back edge. Reducible flow graph. Here suppose 1 to 2. So the node 1 and the edge 2. So 1 to 2. Similarly 1 to 3. And 2 to 3 and 3 to 2. So which has several nodes and transitions, but there is no back edges. There is no back edge. That means which form, even though which form, that is, back edges are required. But in this graph, back edges are there. So remaining are all forward edges, which forms an acyclic graph. So that's why it is a reducible flow graph. So it is an example that is which shows the reducibility. Another important property, another example in another one is here in this example, compilation level. Compiler searches for several instructions, redundant instructions, which are, that means, several times loading and storing of the informations, so that which carry the same meaning. Suppose if it is different, then okay, which is same carrying the same meaning. That means x comma r naught comma 1, register 1. So here instead of moving the contents x comma r naught, we can directly write x to r1. We can write x to r1 and rewrite the instruction. So we can, so registers here we are using so many registers r0 r1, two registers are using. But here instead of that we can use only one register. So that means storing of the instruction several times using takes lot of this one. So compiler it searches for the instruction where the same meaning carried out and eliminated. So these two instructions are replaced by a single instruction which has the performing the same task, which is performing the same task. So here delete the first instruction and rewrite the instructions. So instead of what we are doing, instead see here move x comma r naught, move r naught comma r1. Now here where the contents are to be passed from source to destination. So that is instead of this directly we are passing the x, we are taking this one and passing this contents to her. So it will be very easy to over this one. And another important property is with this example, unreachability code of the program, where the programmers accidentally written a piece of code never be reached. That means here we are going to write a function which has some variable x, and this function returns something that is x plus 10, that means in adding some 10 value. Now we are going to print a value of x. See here in this type of code, printf will be directly we are saying a return statement. This return statement, that means function returns, then one function complete returns means it completes the execution. Function returns means it completes the execution part, completes the execution of function. Then here in this case, this printf statement are not executed. That means control doesn't come to this statement at this statement. It comes out of this one, and this statement is to be available in the program code, but out of getting this one is so here in this case the code is not reachable. This part of the code is called as not reachable, unreachable code of the pro. That means program code is never accessed. Where it never some piece of code is available, but some of the cases it may occurs alternatively and going to the main module or some other sub programs. But in some functions are also, if the programs constructs are not utilized with the meaning of that one, they, for example in this case written several lines of code with the function, but the function is to be completes before the task. That means here the even the presence of x available, but it is not at all using the printf statement. But program code is written, so it is maybe accidentally have written. That is to be identified. The code that is to be a code which is used or not used, and that code can be removed. Lines of code will be removed, so that code optimization will be applied. If code optimization applied, then utilization of the time, that is compile time, will be very less, and faster of running the faster way of running or executing this program. So here the two factors are to be considered. Not only this function with one line of code, like several lines which is to be present, but may not be used for the functionality of that main one. So such statements are to be find. That code is called as unreachable code. That means code is present, uh, piece of code is present, but it cannot access to any other modules or an interaction. That is by mistakenly we have written that. Another application where the selection of an instruction. That means here two factors are to be considered. One is speed, another one is size. One is speed, another one is size. That means, for example, we are going to write an increment statement of the that is instruction format. That is a equal to a plus 1. So instead of writing this one, simply we can write INCA. So this is also same kernel. So some programming instructions, the assembly instruction we can say INCA. So simply we are going to make this one as instruction passing. So we are going to, instead of that a equal to a plus 1, we can make a register with R1, R0 contents and move to this a, and we can pass this constant value a, and then that means here it's just I am going to declare a register A with the register R0 contents, and I am going to add with A. So add A to the register. R0 means here A plus 1. Now the result is stored in R0. So now what is R0? R0 equal to A equal to what is A? Now R0 is moved to the A. So that is finally A equal to A plus 1. So these are the three instructions are to be passed to this one. So instead of passing this, the two contents, instead of passing the three instructions with a separate registers R0 and with variable A. So we can make this one into a command with a single instruction format, that is INCA or A equal to A plus 1 by simply that is address statement. We can say increment A, but if you load that registers and these values also into register and add one more registers and then stores result back into A. So here we have to achieve with what we are by implementing which one to be carried out by, that is speed is one and another one is one. So faster way of execution is also to be considered, but the result is same, and the size of the instructions are also increased based on the implementing by these three factors. So that's why instead of implementing these three, we can write a single source of instruction if it finds suitable for the target machine. So the increment instruction is same result which is performing. So but the quality of the code also be looked out with the variety of factors such as speed and size. Those are the two cases which will. So that is the case of selection of an instruction by means of these two parameters. Previous one is code is to be selected, which one is not attempted as a part of the program that is identified is called an unreachable code. Another one is instruction selection. The selection of the instruction also we consider. That means several registers, loading several times, making the two or more several times with the same repetition of the instructions and registers can be avoided and make use of single registers. And flow graph mechanism where reducibility acyclic, that is acyclic graph which forms a loop back edges and make them into non-reducible flow graphs. So this is the one. Now we are going to look into, thank you, we will come up with the next section with a small next problem with this. Thank you once again.
Like, share and subscribe. Hit the bell icon for more updates.